All right, guys, welcome back. Remember the last lesson we learned all about latitude and longitude. So today's lesson's short. It's about something that's a product of latitude and longitude, mostly longitude, and that's time zones. Remember that the Earth is only facing the sun. Certain parts of the Earth are only facing the sun certain times of the day. So obviously we've created different time zones so that it compensates for the fact that the Earth's rotating into the daylight and out of the daylight. Time zones are 15 degrees apart. They represent 1 hour of time. Why 15 degrees? Well, remember that the Earth rotates a full circle every 24 hours. If you divide the full 360 degrees by how many hours in a day, we get how many degrees per hour the Earth rotates. So in 1 hour of time, the Earth rotates 15 degrees out of a full 360 degree circle. And after 24 hours, that adds up to 360 degrees. In the United States, our basic time zones in the Eastern time zone where we live, let's say it's 3 p.m., because we've rotated into the sunlight first compared to the Central time zone, which is 15 degrees behind us, they would be 2 p.m. Mountain would be 1 p.m. Pacific would be noon, 12 p.m. So these are the time zones in the continental United States. As you go east, time increases by 1 hour every 15 degrees. If you go west, it goes back by 1 hour every 15 degrees. And you'll hear on television, a TV show or a sporting event might start at 8 p.m. Eastern, 7 Central. So it's an hour behind us. Okay, here's a map of our time zones. You'll see we live in the Eastern time zone. Over here, if it's 6 p.m., you can see on the clock, 6 p.m. You go 15 degrees west, you're at 5 p.m., the Central time zone. Another 15 degrees, 4 p.m., and then 3 p.m. in the Pacific time zone. Now you notice these time zone lines do not go straight up and down like longitude lines. And I bet you can come up with a really good reason why. For instance, here's the western part of the Eastern time zone. Well, imagine if you just had the timeline going straight down like this, like a longitude line. You could imagine if that went through your town. One side of town would be 6 p.m., the other side would be 5 p.m. It's not good for schools, not good for business. So what they've done is they've kind of weaved it in and around either state boundaries or places where there's not a lot of people. Okay, moving on. This map here is interesting because it shows time zones of the world, but you can definitely see how the lines don't follow exactly the longitude lines. They're not straight up and down like this. They weave all over the place. Newfoundland actually has a strange time zone. It's not even an hour different from the one to the left or to the right. It's a half hour. It's a very strange time zone. You can ask me about my trips to Newfoundland and how time is kind of screwy there when you first get there, and then you get used to it. You've probably heard of the term jet lag. People who travel across the ocean on a jet airliner, and they get to the other place, and they're either starved for sleep or they've had too much, and that's called jet lag. It takes 3 or 4 days to make up for that. All right. Now, here's the map that's going to teach you about the international dateline. The international dateline on this particular map is located on the right-hand and left-hand edges, 180 degrees around the back side of the Earth. Okay, it's exactly opposite longitude from the prime meridian. So if the prime meridian's here at 0, then if you go around 180 this way and 180 this way, you hit the international dateline, which is the same line here. It's just the map was cut right down the back side. So that's why it's on the left and the right edge. Now, if you're traveling east, remember that as you go east, time goes forwards for each 15-degree time zone. So here would be 1 hour forwards, 2 hours at 30 degrees, 3 hours, and so on and so forth. So you keep going east, you can't keep gaining time. So eventually, we have to back up and reset the clock in a sense. And that's what happens when you cross the international dateline. You have to set your clock back one whole 24-hour day once you cross the line. Now, if you're going west, remember like us versus California, they're behind our time by 3 hours. If you keep going backwards in time, you can't do that. You can't travel back in time, at least not as we know of. And so eventually, you have to make up for traveling back in time and go forwards one whole day. And that's pretty much it for the International Dateline. You go either back one day traveling east or forward one day going west. This is a zoomed in section of the International Dateline in the Pacific area region where there's lots of island nations. And you can see how it gets really complicated. These islands wanted to be all in the same time zone if they're all part of one country. And so there's all kinds of crazy things going on here. I'm not even going to try to decipher it, but you can see that it does get complicated. And that is it for today.